with the last class work, we studied the integration, the PO4 integration, where we just learn about how to find the volume of revolution due to a curve which rotated around x-axis from 2 pi degrees, so the one full rotation, how it's supposed to do. So if you just started with that section, so just I brief that part, so we can get like, if any curve it's rotated around 360 degrees from y-axis, its volume, yeah, 1 second. Yeah, we just work out the volume is equals to pi integration from a to b, the range where the function exists, y squared dx. This was a formula to find the volume of revolution by rotation. Yeah,
Father is in the waiting room.
just added it with it. So if there's a curve somewhere over here, then if you rotate around how many degrees with it? 2 pi degrees, you can one full rotation. That means this forms this kind of a shape. So just like this, if you rotate like this, you can see the shape over here. So it produces a 3D shape. It's a volume. That's what we need to find. Right? Okay. So that was the theory we were learning about in the last class. So if you started some questions in 6b, have you finished the question in 6b, Pati? 6b?
So did 6A, 6B halfway.
Halfway, right? Fadil, how about yours? Right, anyway, let's start this one. So here, if I start the question number 2. So over here, the question number 2, the shape is somewhere like this way around. It's a shape somewhere like this. And this is a region R enclosed by shape. They are not, yeah, in this question, the curves has a diagram. The curve given here is y equals to 5 plus 4x minus x squared, right? Okay. The finite region R is bounded by the curve, the x-axis, and the y-axis. The region rotated through 2 pi degrees above the x-axis generated the solid revolution. Find the exact volume of the solid generated. So in this case, like if you make what kind of a shape is, that's what you have to understand. But shape is not important. But if you know this fact, it's kind of easier for you to analyze this question. So you can say it's a shape somewhere over here, but just so it would be a shape somewhere like this if you rotate it, just like it's a 3D shape actually. It's a shape like this. Like that, you can get this fact. Right, then like how to find this volume, Pute? So according to this theory, we need to find the coordinate over here, Pute, because we know the coordinate over here is 0. It's not a problem here. That means we need the coordinate over here, Pute. So A, so you can say,
Excuse me, sir.
yeah.
So
At A,
Sansha is in the waiting room.
1 second, we'll see. Yeah, I think it's okay. Just, yeah, it's right. Okay. Then Pute, you can see at A, the curve meets x-axis, right? If any curve meets x-axis, what the concept we know, the y-coordinate is equals to 0. That means you can say 5 plus 4x minus x squared is equals to 0. So with that, if you equate it to 0, you get you will get the answer. Yeah, that is -1 and 4 and 5. Answer is 5 and -1. The coordinates are 5 and -1. Minus 1 is here, and this is the coordinate of 5. Therefore, if you want to find the volume, what you need to do is, if you need to find the volume, what you need to do is you have to integrate the curve. You have to integrate, you can say, the volume is the integration from, here we know that function exists from where to where? From not minus 1 to 5, the area is this bit only, they are worrying about this bit of it. From 0 to 5. So it should be from 0 to 5, sorry, the pi times of 0 to 5, y squared. Y squared is this bit. Okay. That is 5 plus 4x minus x squared squared. 5 plus 4x minus x squared squared. So how do you supposed to do this integration? Yeah. Anyway, because there is no other simplified version of this, any kind of integrations for this. Anyway, we have to expand this. But other than that, there is no way of expanding this because it's a some kind of a trinomial, it's not a binomial, trinomial expansion. So you just expand this bracket 5 plus 4x minus x squared, and then you can integrate the individual terms. So that is a way of doing this kind of question. Now to make a, you just try this question. Only thing is that you have to expand this. So this way, 5 plus 4x minus x squared into 5 plus 4x minus x squared. So if you do this, if you multiply with 5, 5 into 5, 25, plus 5 into 4x is 20x, 5 into minus x squared is minus 5x squared, then 4x into 5 is 20x, 4x into 4x is 16x squared, 4 into x squared is 4x into minus x squared is minus 4x cubed, right? Then minus x squared into 5, that is minus 5x squared. Minus 5x squared minus x squared into 4x is minus 4x cubed, minus x squared into minus x squared is plus x to the power 4. So if you do addition of all these things, that is 25 plus 40x plus 6x squared minus 8x cubed plus x to the power 4, right? Okay, so you can find the volume is integration from 0 to 5, 25 plus 40x plus 6x squared minus, sorry, this is 8x cubed plus x to the power 4, right? So with that, if you do it over here, it's pi 25x plus 40x squared over 2 plus 6x cubed over 3 minus 8x to the power 4 over 4 plus x to the power 5 over 5 from 0 to 5. Then substitute 0 at the 0, substitute 5 the function and 0 at the lowest function, then you can get the final answer for that. That's a way of doing this finite integration. So if you get this answer, the answer would be like this. One second. That is turn up to, if you work over here, it is 100 over 3 is the integration of that, multiplying with pi, that would be 100 pi over 3. That is the answer for that. That's a way of doing this question, right? Then yes, then if you come up with a question somewhere like this, question number 3, such thing today, this question number 3, yeah, just a little bit expand this. The question number 3 is, if you refer with this question number 3, it's a curve somewhere like this. Over here, The points given over here is 1 to 8. 1 to 8. The function is y equals to 3 minus cubic root of x. 3 minus cubic root of x, right? So if this is a region, they are just talking about. So if you make a volume of revolution, so if you rotate it for 3 pi, 2 pi degrees, what kind of a shape you receive with it? If you do this, you will get a shape somewhere like this. I just draw the shape over here. No, actually, not knowing the shape is not important for this calculation. Just I'm showing you how it comes. And it's a shape somewhere like this. You'll be getting a shape somewhere like it's just a 3D shape. 3D shape, you are talking about the volume with it, right? So how to get the volume over here is, you can say volume is the pi integration from 1 to 8. 3 minus cubic root is with the x to the power 1 over 3 whole thing squared. That's the answer for that with it, right? Then if you expand it, you get the answer 1 to 8. 3 squared is 9 minus 6 x to the power 1 over 3 plus x to the power 2 over 3. So if you expand it, 1 over 3 into 1 over 3 is x to the power 2 over 3. So with that, you can get this answer. So this is pi over here. It's done up to 9x minus 6x to the power 1 over 3 plus 1 is 4 over 3 over 4 over 3 plus x to the power 2 over 3 plus 1 is 5 over 3 over 5 over 3 from 1 to 8. 1 to 8. So with that, if I just write the rest of the answer over here, so that is pi times of 9x. Here, numerator, denominator, this is 3 go up. 3 into 2 is 18. 18 divided by 4 is 9 over 2. Minus 9 over 2 x to the power 4 over 3. Here also 3 goes up. Let's turn up to 3x to the power 5 over 3 over 5. So you have to put the 1 to 8. So after that, you can substitute it. You do the substitution step. I'm just getting this answer, but you need to show how it comes. 8 to 1. So that is 3 minus. So over here, you get the answer 14.1. So it's just, yeah, 14.1 pi. So you can get this answer. 14.1 is the integration for this into pi. So that is the answer for that. That is how you need to do this kind of integration. I think you can manage the question in exercise 4B, sorry, 6B, sorry, 6B, yeah. So you have to follow up the same context to do the rest of this question. And yeah, the exceptional situations where we can see in this exercise is this question number 11. The question number 11, they have given this, other questions are just similar to the same thing. So you just do this integration only. So question number 11 has a little bit of a exception. They have given this equation in parametric format. X equals to t squared plus 1 and y equals to 3 over t. 3 over t, they ask about the curve rotate for the range of t equals to 2 to t equals to 3. Right, okay. Then what they need is, they need to find the volume of revolution. So volume is equals to pi integration of y squared dx. So if you just do it, you can understand that it's pi integration of y squared is 3 over t whole thing squared into dx. But now the parametric problem, sorry, the variable problem comes here. This equation in terms of t, but the function is in the terms of dx. So we know how to do the correction for this. That is 9 over t squared. This part you can put dx over dt. into dt. Now you can put the boundaries because now the variable become t. Yeah. Then how do you find this part of it, Pute? We know that x is t squared over 2, Pute. T squared plus 1. Therefore, you can write dx over dt is equal to 2t, Pute. Then you can replace this equation. Pi from 2 to 3, 9 over t squared into 2t dt. Then you can get the answer. Pi is from, sorry, yeah, 2 to 3. So that is 18 over t dt. So this is turned up to pi into 18. 1 over t integration is ln 2 to 3. So if you work out, you will understand that that is 18 pi ln 3 minus ln 2. This whole thing comes over here. So this one you can write 18 pi ln subtraction, you can write it as a division. So that's the final answer for that. Okay. So that is a way of doing this kind of a question. So I think now you can manage with exercise 6b with that, right? Then today we are moving to a next integration type of a factor that is called the integration by substitution. Right? This is another important topic where we should know. That's a continuation of the last part of it, but the last integration. So this is integration by substitution, right? That is a topic we are learning today. Right. Now let's go ahead with this, right? Under which situation we need to do this integration by substitution? That's a fact where we have to understand in this topic what kind of integration we use is substitution, right? In our previous PO3 integration, we have already learned if you have a function somewhere like this, you have the integration just like this. Square root of x squared plus 4 times of 2x dx. So in this situation, you can see this is the power function is this. So this is x squared plus 4 to the power half dx. Then you can see here the differentiation of this is available here. So with that, we use the formula integration of fx whole thing to the power n into f dash x is equals to how much? You can write fx to the power n plus 1 over n plus 1 plus c. It's not a problem because the differentiation of this is available here in a straightforward. You can use this formula. So this kind of situation straightforward, you can put x squared plus 4 to the power 2 half plus 3 is 3 over 2 over 3 over 2 plus c. So with that you can say this is 2 x squared plus 4 to the power 3 over 2 over 3 plus is the final answer for this project, right? But like if it is like if you need to add some constant, you can do it, but not the variable. But if you come across a question like this, what is supposed to do, right? You get the equation somewhere over here. 2x plus 5, the square root of it into x dx. Right? This is x. Right. Okay. Now you can see here the differentiation of this is, so if you just write like this, 2x plus 5 to the power half into x dx. Now what you can understand is here the differentiation of this is 2, but its differentiation of this is 2, but it's not available here. So in this kind of situations, we use this method called method of substitution to do it. Let's see how to do this question. Right. Yeah. So I just do it and show you how it comes. I'll do a little bit of addition for this question and I just do it today. Yeah. Am I correct? So the question is 2x plus 5 to the power half into dx, sorry, into x dx. Into x dx. Usually they used to give us a substitution, but if it is not given even, we can do the technique like this. Usually we take this power term, the expression inside the power term, and assign a variable for that. Usually it comes with some kind of u or something u is equals to 2x plus 5. We will get in that way. We'll get into, or sometimes you write u squared. It depends on the question for this. So you just substitute u and see whether it comes. If it is not, you just put u squared and see whether, because basically there are a lot of substitution we can do it, but in our curriculum, that is the main things we can concern. So in that case, for this integration, what are the things you can make it for this integration with this variable? I have assigned the u as 2x plus 5. So the first part of the function turn up to u to the power half. Now this is completed. This part you can replace with 2 to the power half. Now there are another two facts where we have to complete. So in this case, Pate, you can write du by dx. If you differentiate this, what do you get, Pate? You get 2. Therefore, you can write du is equals to 2 times of dx. Therefore, you can write dx is equals to half du. Then instead of this one even, you can put half du. Right. Then there is another section we need to fill up, that is the x. So this x, we have to replace something x from here. So from this function, you can say from here, you can write x is equals to u minus 5 divided by 2. So you can replace it's over here. U minus 5 over 2. Right. So then we can expand this brackets. So if you expand this brackets, turn up to u to the power half into u is u to the power 3 over 2 over 4. I just integration, it's not simplified yet. Minus 5 over 4 u to the power 1 over 2 du. Now you can do this integration. So this is turn up into 1 over 4 u to the power 3 over 2 plus 1 is 5 over 2 over 5 over 2 minus 5 over 4 u to the power 3 over 2 over 3 over 2 plus c. So then you can simplify. So you this 2 goes up with 1 over 10 u to the power 5 over 2. This 2 goes up. That is 5 over 2 to get cancels, 5 over 6 minus 5 over 6 u to the power 3 over 2 plus c. You can get the final answer for that. Now we don't, because our functional variable is x, therefore you cannot just write in answer in u. So what you need to do is now you can replace with this u. Let's turn up to 1 over 10. You can replace with 2x plus 5 to the power 5 over 2 minus 5 over 6 times of 2x plus 5 to the power 3 over 2 plus 6 is the final answer for this. That's a way of doing this kind of a question. Right. Like that, you can do this substitution. Then in part B, they ask you to do the same question with a different substitution. But that's what I mentioned. Sometimes we use different kind of substitution to do the same question. Both may be successful. Sometimes only one may be only successful. Let's go to the next substitution. That is this part. The question is to integrate the same question I'm working out with a different variable. 2x plus 5 to the power half x dx. The substitution they referred us to do is u squared. U squared is equals to 2x plus 5. Right. That means over here, so this is u squared to the power half. Let's see. plus method, you have to fill up these two, right? So you can say this is, if you want to get, yeah, if you differentiate it, what you get u squared, answer is 2u du by dx is equals to 2. So you can cancel u and u and can write u du by dx is equals to 1. That means you can say dx is equals to u du. Yeah. So you can say x is replaced by u du. Right. Then we need to fill up with this exponent. Right. From here you can write x, if you subtract x from here, u squared minus 5 divided by 2. So this is fill up with this. U squared minus 5 divided by 2. So if you expand these brackets, you can understand that that is u squared half is u into u squared minus 5 over 2 times of u du. So if you expand these brackets, turn up to u to the power 4 over 2 minus 5u squared over 2. Integration. With that, you can get the answer u to the power 5 over 10 if you integrate this, minus 5u to the power 3 over 6 plus c. Now you can see the same concept you can work out. Then you can replace with this one. The method replace growth. You get the answer. Here you can write u to the power 5 is 2x plus 5, because u is 2x plus 5 to the power half. Half whole thing to the power 5 minus divide by 10 minus 5 over 6, the same concept, 2x plus 5 to the power half to the power 3 plus c. So with that, if you expand it, you get the same answer further. So this answer is 2x plus 5 to the power 5 over 2 over 10 over 10, yeah, minus 5 over 6, 2x plus 5 to the power 3 over 2, right? Like that it comes. So the say, I think the same question, same answer where you get over here. So whatever the substitution, but this is not applicable for all the questions. Sometimes certain substitution may be not much appropriate to get it, but anyway, most of the situations where we can work out. Now the problem is that yeah, so in this situation, there is another concept we have to understand. Integration by substitution is only one way where we can, which is coming exceptional with this. Again, just like this, if this integration of fx to the power n into gx, it's not differentiation. In that case, you have two approaches of doing this question. But the only one approach is integration by substitution. Other one is called the integration by parts. Integration by parts. Integration by part, other one integration substitution. So how do you verify whether in under this situation, like if it is a question somewhere like this, here. So if you come up with this question here, the differentiation of this is not available here. It's not here, right? Integration is not here. Therefore, whether you have to go for substitution or the integration by parts. Usually, if these two functions are with the same type of it, if this is like some kind of a polynomial type and this one also polynomial type, you can go ahead with integration by substitution. But if these are two different types of functions, just like suppose that this is polynomial and this is just like some kind of a exponential function or like some kind of a trigonometric function. In that situation, we have to go ahead with integration by parts. We'll come up with that kind of question a little bit later. Yeah. Right. Let's go to the next question today. Right. Yeah. If I come across this kind of situation, so it's just like this. Suppose that you need to integrate cos x sin x 1 plus sin x to the power 3 dx. Now it's a product of two different functions. See whether the differentiation of any of these is over here and the differentiation of this is over here. No. The differentiation of 1 plus sine x is just like that, but there's another sine x there. So it's kind of hard for to use the previous format for this case, and you can understand that both of them are trigonometric type. Therefore, the best way of doing the substitution, best way of doing this integration is integration by substitution, not integration by parts. Then integration may, if it comes to question somewhere like this, maybe 1 plus sine x to the power 3 into e to the power x dx something. So in this situation, these are not same type of function. So in that case, the much preference goes to not with integration by substitution, but integration by parts. Later on, we'll come with integration. What do you mean by integration by parts? But for the moment, remember, since these are this way, so I can use a substitution like this. U equals to 1 plus sine x. I'll get it. The term inside the bracket, I'll just assign a variable over here. Therefore, what happened to this integration? So this integration now turn up to here, u to the power 3. Then you have to fill up dx, sine x, and cos x. Then if you differentiate this, what do you get? Du by dx, what do you get? You get as a cos x. Then you can write du is equals to cos x sine x, sorry, cos x dx. Now you can see in this integration, this whole thing is completed over this part. This whole thing is completed with this, right? Yeah. So instead of that whole thing, you can put what? Du. I think you can understand what I mentioned. So here, if you differentiate this function is cos x, so the cos x dx is du. So here the entire cos x dx you can replace with that. Now there's still we have something remaining over here, the sine x part of it. So you can write from this function from here, sine x is equals to u minus 1. So now you can replace over here, u minus 1, right? Okay. Then if you do this integration, it's turn up to u to the power 4 minus u to the power 3 du. Now if you do it, u to the power 5 over 5 minus u to the power 4 over 4 plus c. Now you can work out this function of it. 1 plus sine x over 5 minus to the power 5, 1 plus sine x to the power 4 over 4 plus c is the answer for this. That's a way of doing this kind of a question, right? Okay. Then now if this integration comes with some kind of like some powers as well, just like this, it's if it is some kind of a finite integration, how do you deal with this? Suppose that get a question somewhere like this, from 0 to 2 x plus 1 to the power 3 dx. Now here it's a two different functions. There's a differentiation of this is not available here. Therefore, either they are for this question and only of course you can expand it and you can do it even. But if you use a substitution, how to do it? So you get u equals to x plus 1. Then this integration turn up into u. Now we have to fill up these two facts. So you can say du by dx is equals to 1. Therefore, du equals to dx. Now dx you can replace with du. Then x. From here you can say x is equals to u minus 1. So you can fill up over here. U minus 1. Now there is another fact we have to do. Now the
So isn't it u cube? That's u cube, right? X plus 1 cube. So
yeah, sorry, it's u cube. I just made a mistake. Sorry. This is u cube. Yeah. That's great. Then there's another fact. You can understand that these two boundaries. These two boundaries are there for x. Therefore, you need to, if you do this fact, what you need to do is you have to change the boundaries as well. The boundaries for x are 0 and 2. Now, if you work out over here, what are the u answers? U. That if you put 0 here, answer is 1. If you put 2 here, its answer is 3. So you can put 1, 2, 3. Then this is turn up into integration from 1 to 3, u to the power 4 minus u to the power 3 du. With that you can write u to the power 5 divided by 5 minus u to the power u to the power 4 divided by 4 and from 1 to 3. So if you do this, this is 3 to the power 5 over 5 minus 3 to the power 4 over 4 minus 3 to the power 1 to the power 5 over 5 minus 1 to the power 4 over 4. Excuse me for 1 minute. Okay. Right. Then Pate, you can get this final answer for this Pate. Right. Okay. If you do this fact of its turn up to 3 to 1. 142 over 5. Pate. Yeah. So this answer become 142 over 5. Right. Okay. Right. Then Pate, there is another approach where we can do with this is it's just like this. So over here, if you want without changing the substitution, Pate, you can do another way of this. I just use a different color to show that how to do that kind of situations, Pate. From this step, we can follow up this way as well. Without changing these boundaries, you can just do this u to the power 4 minus u to the power 3 du. Without changing the boundaries, you just do it without substituting the boundaries, Pate. Then this is turned up to u to the power 5 over 5 minus u to the power 4 over 4. This is the second method, method 2. Without changing the boundaries, how to do this question, Pate. So with that, now you can replace u is, how do you get Pate? We know that with the substitution, what you use is u equals to x plus 1. Then you can use this part of it, Pate. You can write this is x plus 1 to the power 5 over 5 minus x plus 1 to the power 4 over 4. Now you can do the substitution of x values over here, because the facts value you have to substitute for x is 0 to 2. Then if you do this 0 to 2 even, you get the same answer back. So you can say this is 2 plus 1 to the power 5 over 5 minus 2 plus 1 to the power 4 over 4 minus 0. Substitution is 0 anyway. If you do this even, you must get the answer of this one. So that's a way of doing this kind of a question. Right. Okay. Right. Okay. So that is the fact we have to understand about the integration by substitution. So you can check with the exercise 6C and come up with the hard questions from next class. We'll be discussing how to do the questions in that exercise. So with that, we'll come up with the rest of the topic.